Hello class, welcome to Unit 4, Lesson 3, Law of Logarithms. Today we're going to go ahead and evaluate logarithmic expressions, use the law of logs to expand and combine, and then the change of base formula or calculator to evaluate logarithms. We did this last piece yesterday in class. So, who invented logs? John Napier from Scotland. Who was he? He was a Scottish mathematician. He did not graduate from college, was a wealthy and successful businessman. He invented a calculating tool which used marked strips of wood or bone side by side to multiply or divide. So if you've ever seen kind of this lattice work over off to the side. And then he also introduced the decimal notation for fractions. So he's probably one of your favorite people because I know you guys prefer decimals over fractions. So some reviews about exponentials before we get into law of logs, because exponentials and logs undo each other. Remember, if you are multiplying, you are going to go ahead and add exponents. So we have a to the m plus n. So when we talk about logs and exponentials, there's a property with multiplying and adding that go together. Okay. When we are dividing, we subtract a to the m minus n as long as the bases are the same. So division and subtraction go together. And then taking a power to a power, we go ahead and multiply those. A to the m times n. Okay, so those are exponential rules. Now let's move into our law of logs. So here, if you have two things inside of a log that are being multiplied, you can go ahead and separate them with addition. Okay, so a times b, so it's log of base a of a plus log base b of b. If you have division, you can separate them with subtraction. And then the last one, if you have a power to a power, you can make it become multiplication. You take this c and bring it down in front. That's like the nicest property for solving applicable problems, where you can take the exponent and bring it down in front. So we are going to condense or combine logs. So what I always do is look for numbers other than 1 in the very front. If there's a number in front, that means it was an exponent. We should put it back. But I do not see any numbers in front on the first one. So we're just going to go ahead and combine it. It is addition, so we're going to rewrite it with multiplication. So it's log base 4 of 2 times 32. And I would actually, if you can, what is 2 times 32? It is 64. So we will have log base 4 of 64. And since this is all one number, I would check to see if it is possible to type into your calculator. If you type it into your calculator, you'll actually see that it is an answer. It is 3. Okay. The next one, log base 3 of 9 minus log base 3 of 81. Okay. This is subtraction, so we are going to put it back together with division. So I'll have log base 3 of 9 divided by 81. If I reduce this, 9 over 81, it would be 1 over 9. And once again, if you type this into your calculator, you get this answer. I'm going to walk you through how you would get it. You would think, how can I rewrite 9 as a base 3? Okay. Well, I know that 9 is really 3 to the second power. And then if I take 3 and move it up to the numerator, we have log base 3 of 3 to the negative second. And as we've discussed previously, if the log and the base here are the same, they cancel and you are left with negative 2, just the exponent. Okay, so you could have also went even way back here and typed it into your calculator and seen if it was an exact answer, like an integer. Otherwise, if it's not, please just go ahead and leave it as a log. Okay, if it's like a decimal that continues on, just leave it written as a log. Expand. So now we're doing the opposite. I really have 8 times x squared. So I can separate with addition. Log base 2 of 8 plus log base 2 of x squared. The other thing, in order to be fully expanded, you must go ahead and take any exponents, if they're not a 1, and put them down in front. So it's a 2, so I'm going to write it here. So it's equal to log base 2 of 8 plus 2 log base 2 of x. And there it is, completely expanded. Some warnings. People try and do this all too frequently. You cannot think about this as like distributive. This does not work. Okay, so you got to get in your head the properties of logs, okay? So this is true. Log base 2 of x times y is equal to log base 2 of x plus log base 2 of y. But it's not true this way, okay? Division, people think they can break it apart again. This is not true. Log base 2 of 12 divided by 6 can be rewritten as log base 2 of 12 minus log base 2 of 6. Okay, those are the same. This is not true. And then the last one, this is saying the whole log is being taken to the third power. It has to be just the x. Okay, that would then equal 3 log base 2 of x. If the whole thing, though, is you cannot rewrite it. Okay, so these are common mistakes. You're gonna have to make sure you get these rules down in your head. Okay. All right, so let's go ahead and do a little bit more condensing or evaluating. So I see subtraction. So I'm going to go ahead and rewrite it with division. So it's log base 4 of 192 divided by 3. Then I would actually take 192 divided by 3, which is 64. And I would try and think about, I could type this in my calculator and see if it works. I would also, if I don't have my calculator, the way this works is I would say, since it's a base 4, I would say, can I rewrite 64 as 4 to some power? 4 squared is 16, 4 to the third is actually 64, so I'd rewrite it as 4 to the third. The log base 4 and this 4 are the same. We cancel them, and we are just left with 3. Okay. B, we have addition, so I'm going to rewrite it with multiplication. So I have log base 4 times 25. So this is really log, I didn't mean to say log base 4. It's log of 4 times 25, and then it's log of 100. Now if it's not written, it's really log base 10. So I would say to myself, is there a way to rewrite 100 as 10 to some power? Yes, 10 squared, and since this is the common log and this is 10, these would cancel. So you would get 2. Okay. However, could you have typed in log of 100 on your calculator and gotten the right answer? Yes, you could have. All right, the next one, I would go ahead, we have to expand it, take the 100, move it down in front. Then we have times log base 4 of 16. So let's figure out log base 4 of 16. It's 100 times log base 4, and then I would say, can I rewrite 16 as 4 to some power? Yes, 4 squared. The log base 4 and the 4 cancel, so now I'm left with 100 times 2, which is an answer of 200. Okay. That is example 1. So there we went ahead and we were condensing and evaluating. Here we need to go ahead and use our logs to expand. Expand means to make bigger, so we're going to write it out the longest way possible. Okay, so in here, I see that this is really 3 times x. So I'm going to rewrite log base 3 of 3. Multiplication is then rewritten with addition, log base 3 of x. I would look, is there any of these I can simplify? This kind of clues me in that there might be a chance. This is to the first power. So log base 3 of 3 is really just 1. So it would be 1 plus log base 3 of x. And I can't simplify log base 3 of x because I don't know what x is. All right, B, multiplication. We are expanding. We have log base 2 of x plus, because it's multiplication, log base 2 of the square root of y. Okay. Well, square root of y, we actually need to rewrite as the exponent. Every time you guys have a square root, maybe something to note, if you have the square root of x, it's really x to the 1/2. Okay. And just another reminder, if you have the cube root of x, that's x to the 1/3. I could continue on. The 4th root of x is really x to the 1/4. And essentially the nth root of x is x to the 1/n. Okay. So any of these forms, you can rewrite them as exponents. So this is log base 2 of x plus log base 2 of y to the 1/2. And so I need to, in order to be expanded, I need to go ahead and move this all the way down in front. Be careful where you put it. It only goes with in front of the log of y, so it's just going to go right in front of here. So our answer is log base 2 of x plus 1/2 log base 2 of y. That would be our final expanded answer. All right. This next one, ln's. ln's are expandable the exact same way that logs are. I'm just going to quickly move this on to the next slide. So I'm going to expand this one. I first see addition. Sorry, it's going to be addition because it's being multiplied. So I have ln of x plus ln of the square root of y over 2. Square root of y over 2. So now I would say to myself, this is really ln of y over 2 to the 1/2 power. I can do this in two different ways. Okay, option one is to take my 1/2 and put it down here now, but then you must be careful. Okay, so we're going to continue expanding. Here's kind of option one. You can think about it either way. You could, we'll have ln of x plus, then it's 1/2 ln of y over 2. Then you have to still break this down or expand this because it's division, so we're going to rewrite it with subtraction. So it'd be ln of x plus, now this 1/2 goes to all of it, so bracket ln of y, division, so minus ln of 2. Then you would distribute your 1/2. So your final expanded answer would be 1/2 ln of y minus 1/2 ln of 2. That is one way you can think about it. The biggest thing, though, you have to see is the 1/2 is actually going to both the y and the 2. Okay. Your other way to think about this would be to go from this step, and I would just do a little rewriting. We'd have ln of x plus ln, and then if it's a power to a power, it's really y to the 1/2 and 2 to the 1/2. So I have y to the 1/2 over 2 to the 1/2. Then I would go ahead and break it down from here. So we'd have ln of x plus ln of y to the 1/2 minus ln of 2 to the 1/2, and then we would bring those exponents in front. Because this would be 1/2 ln y minus 1/2 ln of 2. And you would see that these are the same answers. Either way you think about it is fine. Do you need to show as many steps as me? Probably not. You might need to show a few. Some people might automatically, especially on these easier ones, you don't need to rewrite this. You could just say, oh, I know this is 1/2, so you can write 1/2 in front. Sometimes some of you are going to get really, really good at it and just be able to expand it all in one step. So either way you want to think about it, they both work. Okay. All right, so we were expanding. Now we're going to go ahead and combine. So the last thing we did when we expanded was to put the exponents in front. So now we need to make sure we put them back. So I look at example A, and I see there's a 1 here, so I'm not worried about that. But this is a 5 in front, so it returns here. So this will now equal log base 3 of 5 plus log base 3 of 2 to the 5th. And I might actually say what 2 to the 5th is. 2 to the 5th is 32. So I will have log base 3 of 5 plus log base 3 of 32. Now I have addition, so I need to put it back together. Addition goes back together as one log with multiplication. So it's log base 3, and I'm going to skip this next step. It's really just going to be 5 times 32, and 5 times 32 is 160. And I do believe we cannot do log base 3 of 160 as a nice integer answer, so we will just leave it written that way. Okay, if it would have simplified to, let's say, 5, then you'd write it out, but it doesn't. So leave it like this, unless the directions say to round, then you type it in. Okay. The next one has ln's. Same idea. They go back the way the exponents go back in front, back as exponents. If they were in front, they go back as exponents. This is a 1, so we're good. This is a 2, so it goes back. This is a 3, it goes back. So this one is ln of 5 plus ln of x squared plus ln x squared plus 5 to the 3rd. Okay. And now I see that they're all being added, so essentially we could jump to the conclusion, and all of those will be multiplied together. So if you wanted to write it right away that way, that's probably where we would go. You could take it step by step and say these are being multiplied, but essentially multiplying all of these. So ln of 5 x squared, and then x squared plus 5 to the third. And if you wanted to, you could, but you'd have to write this thing 3 times and FOIL it if you wanted to. So this would be totally acceptable answer. Okay. C. Well, same idea, looking for numbers in front, we need to return them. So this is really log base 2 of x to the 5th minus log base 2 of y. Then it's subtraction, so we are going to rewrite it with division, log base 2 of x over 5 divided by y. And that is our final answer. That is as far as you can go. All right, your turn. Take a second, pause the video please, and give it a try. Then I'll come back and I will do this one. So hopefully pause it. Exponents need to go back. So we will have log base 7 of 5 to the third minus log base 7 of x to the 1/2. Okay. 5 to the third is really 125. So I have log base 7 of 125 divided by x to the 1/2, which is the same as the square root of x. In this case, do we leave square roots in the denominator? No. So we would rationalize the inside piece to times by square root of x times by square root of x. So we'd have log base 7, 125 square root of x all over x. And that would be your final answer. Okay. Same thing here. Take and put our exponents back where they belong. Then I would have log base 5 of w to the third plus log base 5 of x to the second minus log base 5 of 6. One thing I'll say is make sure your logs are all the same. They have to be the same log base in order to put them together. Okay. So from here, we can kind of see what's going to happen. We're going to have this times this, and then it's going to be divided by this. So if you want to just jump to that conclusion, you totally can. Otherwise, you can take it step by step. So it's log base 5, and then these two are going to be multiplied. W cubed times x squared minus log base 5 of 6. And then we would have log, equals log base 5 of, writing it as 1, w cubed x squared divided by 6. That would be our final combined answer. Okay. The last one on here is that we need to expand. Okay, so what I would see is that we have x squared times y to the third. Then we have division. So this is going to be broken apart by addition. This is going to be broken apart with subtraction. Okay, so we will have log base 5 x squared plus log base 5 of y cubed. Now division, so minus log base 5 of, and I'm going to rewrite this right away as 3 to the 1/2 power. Then our last step is to take our exponents to be expanded all the way and put them down in front. So we have 2 log base 5 of x plus 3 log base 5 of y minus 1/2 log base 5 of 3. Ooh, that looks bad. Log base 5 of 3. Good. All right, so hopefully you did well with those when you practiced on your own. Last thing, change of base. So we went ahead and we actually did this on our calculators yesterday for those of you who are, didn't have an updated version on your calculator. So if you need to, if you don't have this button on your calculator, remember it's log base, and you can find it under math, and then if you scroll to the bottom you'll find it, okay, on your calculator, and it should, for the most part, everybody should have this. If you don't have it, then you have to use the change of base formula. So it is log of x over log of a. They mean the same thing. And if you wanted to, you can use logs or ln's the same way as logs. It'd be ln of x over ln of a. Whatever the base is goes here, okay? Which makes sense because it's a little guy. It's kind of on the bottom like a fraction-ish if you wanted to think about it. So there is that. So use your calculator and evaluate. So if you can type it into your calculator as log base, you would. Otherwise, you would go log of 12 divided by log of 2. And I would make sure you can do this on your calculator. But if your calculator has this function, use this function. Okay, if you can type it in this way. Otherwise, when you type it in and you round to 6 decimal places, because that's what the directions say, it'd be 3.584963. Okay, and the next one, you would have log of 3.28 divided by log of 9. So you can type it in this way or this way, and then when you type it in, you should get 0.540611. Okay, and that should be your answers for those. So, homework, 356 or PDF 385, 2 through 56 even, and then also review section 4.1, 4.3. You will have a quiz tomorrow on those sections. Okay, so make sure you do both, and I will talk to you later. If you have questions, make sure you write them down, and then we can go over them tomorrow. Have a good day. Thanks.